So later I will open a file, but right now I don't know for generating random vectors, quadratic random variables, and stochastic process. No, this one I will skip totally. And about arriving process, right now I think we know how to have a person, right? And if we have the different rate, sure, we can find the time period to have the suitable rate to have the generation. So non-stationary, then we can follow the algorithm. Find the suitable lambda and generate according to that lambda. For example, here. All right, for example, this one. And about batch size, actually, we don't know. We need to generate B and also find the time instant. So use B and also the time instant so that we can return the arrivals. And that's all. Well, actually, we don't have the answer for you, but later I will let you have. And before we go, in fact, we're almost near the end. And actually, we go through general approaches to generating random variables. But I skip continuous random variable. I focus discrete random variable. For discrete random variable, let me ask you this question. Generating discrete random variable. Table lookup within the category. Table lookup, correct? Table lookup. Ratio, yes or no? Yes. And the Masaccio table within discrete, generating discrete random variable, correct or not correct? And finally, Alice method. Alice method for this one, to generate discrete random variable, we have for the setup this one. This one for discrete random variable. The answer is yes. We talk about table lookup. We talk about Masaccio table. We talk about these. These for discrete random variables. Right? Because I go through quickly, so that's why I ask you intentionally to refresh your memory. Well, that's all. So we go through all of these. And finally, we go through quickly for arrival process. Actually, arrival process, non-stationary person, that is all in chapter 6. Batch arrival, same in chapter 6. So I go through quickly. Well, so this is the quick review. So what we've gone through, we already have all of these. And finally, yes. Let's check this for you. So maybe let me let it have the solution directly. Originally, I have a file. Perhaps I will upload the file to you for reference. But let me check this for you quickly. Well, So we have these, and we have C and D. C and D, right? But we focus C. If we focus C, C is minus value. All right, and we have a probability Fk. Fk set here, so we have a U lower than or equal to Fk. And then we remain. But if we have a U greater than this setting, then we should set L equal to M. Right? So this is a probability remain. So remain says we have 1/n+2 to choose K. And what's the ratio? To remain. The ratio is 1n+1 plus C, right? But this is a ratio. And the ratio, if we want to transform to probability, it should be this over this. And so that we have 1 plus C multiply n+1. So this is probability. And this probability is exactly equal to Fk. Do you agree? For example, a quarter here. Plus C actually is minus the absolute value of that part. For example here, 0, we should minus this here. So that we have the remaining one. The remaining one, we pass on 1/n+1. So over this one should normalize. Somehow this is conditional probability. Under this condition, right? So C is negative, so of course the current value 1/n+1 plus C, that says minus that here. And so that this is the remain portion. And with the remain portion pass on the current of B 1/n+1, then it's the probability remain in the same index. And so then it should be Fk. Well, about this, take a picture first. And then you can think about later after classes. So Jerry, can you take a picture first? Okay.
Okay.
And you can keep thinking. And while we have the setting for this.
Professor, assume that we have x equals to 0.
0, 0, 0.
X equals to, we want to output x equals to 0. So we just times 0.25 times.
If it is 0, then 0 only we choose 0. And if the probability lower than 0.4, U.
So
we have a quarter multiply 0.4. A quarter multiply 0.4. And so that we still have 0.1 as desired. So that we still have 0. Is that correct?
So if we want to output 1, then
output 1, then we can have 0, but the probability should be greater than 0.4. So it should be a quarter multiply 0.6.
okay.
0.6. Well, if you have any further questions, just let me know. Well, if no, I'll assume you know the answer should be this. So finally, we should have this. So that says we have the setting for Fk. Well, we finished all, but I expect to have the whole from all of you. This one further. We think about this. What are you most worried about? Initially, we asked you this poll, right? But right now, after going through all the lecture, we think about this. You worry about exam in English? You worry about homework in English? You understand lecture in English? Or other, or maybe none of the above? I think you understand we have a poll like this, right? But right now, after going through all the lecture, so we think about this. Okay, so check it.